Chief of Police. I've worked in a forensic lab for 5 years. I was a homicide investigator for the state of Vermont, level 1 homicide investigation. I've been fiddling around with computers since '73, and I've actually contributed to an ANSI standard for fingerprint data that gets exchanged with the FBI. So I've got kind of both worlds covered here. And I'm also, this is my blatant, cheerfully blatant plug, I'm also the author of several computer security books, or co-author. So here's our agenda for today. We're going to talk about just all this stuff, how it ties together, how the math works, how the computers work, and how some, whether this stuff is doing the right thing or it's doing the wrong thing. That's kind of a moral question that maybe we'll entertain, but we want to talk about what's actually going on a hardware level and on the streets. So
we can skip the videos. We can skip the videos.
Okay, skip. All right, so part of the thing is that police investigations are all about collecting data. Now, if you talk to the average cop and you say that you're in information security, or you're working in an information business, they'll look at you like you got two heads. Cops do not think about data as in the way that you guys think about data. They think about it as who, what, when, where, how. But that's also the same stuff that anybody's collecting for basic demographic information, all that kind of stuff. It's exactly the same thing. But they just don't look at it that way for the most part. I would mention things like this, and people would look at me like, what are you, nuts? We're out there to enforce law. We've got nothing to do with collecting information. Yet everything we do is collecting information day in and day out. You take away an investigator's gun, he can probably do his job. You take away his pencil and his computer nowadays, he can't do his job. The police investigations do differ from a lot of other data collection in a couple of key areas. First of all, everyone lies to the police. Everybody lies to the police. We have to separate the lies from fiction, the opinions. We get false positives all the time. I can't tell you the number of people I've had confess to crimes they don't even know about. I've had people that would literally walk up to me and confess to killing JFK before they were born, things like that. Eyewitnesses have a high credibility with juries and courts, but they don't work very well for police for the most part. We love them when we can get them. Someone that's real positive to stand up there and say something. Unfortunately, eyewitnesses have a tendency to rather contradict each other. Every time I had multiple eyewitnesses, the crime was committed by a tall, short, heavy-set, thin, white, black guy who may have been a woman. So, and then everybody lies to the police, including witnesses that are trying to cover up things about themselves they don't want discovered. And one of the last things is if the police departments fail in their investigation, overall that can be very dangerous to the public. And then the final thing that makes it difficult for us is that everybody lies to the police. Okay, so sometimes, like I mentioned, you could probably take away a guy's gun, but you can't take away his pencil. Joseph Wambaugh recognized this in one of his novels. And the cops are starting to recognize this somewhat. But it's still kind of a long way off. He mentions here that Clarence looked around at the roar of the activity at the grinding paper mill. Paper everywhere. Take away my gun and car, but please don't take my pencils. And that really sums it up, because detectives are out there collecting information. A lot of times they just don't think of it as data. They tend to be more like our friend Sipowicz here, who says you walked in with a pretty face and information. You can't leave with both. It is changing, but people are starting to finally recognize that it is, in fact, data that they're working with and they can manipulate. So now the public is starting to realize this because we've got these fun shows like CSI. There's actually a CSI effect that prosecutors talk about in court. Juries want to see fun stuff where the videos come up and we have things flying around on the screen. It's all animated, and the DNA is instantly available, and it just doesn't quite work that way. Some of this stuff is true. We have DNA testing, obviously, nowadays. We have automated fingerprint systems. To pick on those two, because they did work closely with those in the forensic laboratory, DNA testing, some types of it can take literally weeks. It's not like on CSI where they walk in and say, oh, here's a match to our bad guy. It doesn't work that way. APIS search is very similar. You can get actually several hundred categories that you have to search through by hand. That's narrowed down from tens of thousands, but it's still, you've got to do a hand search and do the final verification based on a person. We've got, things like school-associated violence is actually dropping in years. It gets a lot reported more often, but it's actually dropping. And the other thing that is percepted by TV shows to the public is that we have a really exciting lifestyle. We get in gunshot fights all the time. We get chases, high speed. I can count on a number of times, like one hand, the number of times that I actually got involved in gunfights, and I can tell you the number of chases I got involved with over a 20-year period was probably about 10. They're fun when they happen, but it's not like So, knowing all that stuff, we're going to talk about tools that are available to investigations in the real world and how this stuff actually works. So, time for science. Here's mine.
I want to start off by defining math to be very broad. When we're talking about math, we're talking about physics, anything that is using calculations, from simple calculations to advanced computer algorithms. So I want to give you that broad definition, because a lot of stuff we're talking about is not necessarily math at its base, but uses math. For example, accident reconstruction is all about physics, but it's math. Now, math is everywhere, and more than just simple addition and subtraction. With the elections going on, there's lots of math. Delegate counts, super delegates, proportional allocation of delegates, voting, exit polls, voter identification and analysis. All of this is mathematics that, if you're a voter, it's directly impacting you. In sports, you have your statistics. Baseball is the sport of sabermetrics. You can look at, a chart that I saw recently was analysis of Roger Clemens, ERA and WHIP, depending upon where or when he may have taken steroids and whether or not that impacted his career. Betting in sportsbook, it's all math. The lottery is probability, or perhaps improbability, because lottery math will tell you the best way to win is not to play the game at all. And then math and advertising. The company in Germany, a company in Germany started determining that you could charge more for a billboard if you knew that more people drove by that particular portion of the road. So that billboard now costs more. And now they can find out what sorts of people are driving by that billboard. So they can identify and even micro-target that billboard to the types of people that are driving on that road. And then we'll look at these two advertisements. You may have seen this last year. This was an advertisement that was put up on a billboard in California. Find the first 10-digit prime found in consecutive digits of E, which is based on the natural logarithm. When you figured out that 10-digit sequence and went to that website, there was another math problem, and when you solved that, it was basically a job search by Google. They were searching for people who were smart in math. This is a British £2 coin that came out in 1998. I won't belabor the point too much here, but the coin here was designed as a kind of to show the advances in technology. And actually you can see on the silver layer there, it's kind of a computer circuit board, and then on the inner layer you have a series of gears there. Well, if you sat there and counted those gears, you'd find there's 19 gears. If you know how gears work, if one gear is clockwise, the adjacent one is counterclockwise. So if you start clockwise, counterclockwise, you're going to get to two gears that are supposed to turn clockwise, so those gears will never turn. They didn't realize this until after the coin had been printed. So can math and computer